Hello friends, and welcome to our next session of Stiffness Matrix method. Today we shall solve one portal frame by Stiffness Matrix method. So as you can see in the diagram, there is one frame having one internal hinge here on joint B. We have been given an internal hinge and there are three members meeting on joint B. So our first step, as usual, will be finding out kinematic indeterminacy for this frame. So let us find out kinematic indeterminacy. So how to find kinematic indeterminacy? Yeah, let us see. First of all, see how many number of joints are there. There are 4 joints: A, B, C, D. Assume each joint without any support. So if you assume a free joint in space for a beam or frame, then we will have 3 degrees of freedom per joint. So 3J will be 3 into 4. 3 is 3 degrees of freedom. 2 translations, 1 rotation. So 3 into 4, 12. Then see how many number of support reactions are there. Support is fixed, so 3 support reactions. C and D both are hinged, so 2 each. So 2 plus 2, 4, plus 3, 7. Okay, so 12 minus 7 will be 5. From this, we will subtract some more things. How many members are there? AB, 1 member. BC, second member. BD, third member. So 3 members for axial rigidity. So we are going to neglect axial rigidity of these members because they are flexural members. So 12 minus 7, 5. 5 minus 3 is 2. So 2 rotations on C and D, and there is one more internal hinge. So 2 plus 1. So actually kinematic indeterminacy for this frame is 3. If there is no internal hinge, then it is only 2. So Ki is 3. Which are those 3? Theta B, theta C, and theta D. So we shall give numbering to all these unknowns. So let delta 1 is equal to theta B, delta 2 is theta C, and delta 3 is theta D. Okay, so this is our first step, kinematic indeterminacy. Now fixed end moments. Okay, fixed end moments. So let us find out one by one. First of all, span AB. So MF AB, so it is minus WL square by 12. So minus 20 into 4 square upon 12. Okay. So let us see how much is this. So minus 20 into 4 square by 12. So it is minus 26.67. Okay. Then MFBA, it is plus WL square by 12. So it is obviously plus 26.67 kilonewton meter. Then MFBC. MFBC is MFBC central point load, so minus WL by 8, so minus 25 into 5 upon 8. Let us see how much is this. It is minus 15.625 kilonewton meter. And then MFCB, it is plus 15.625 kilonewton meter. last one is BD and DB. We shall start with D. So MFDB is, it is a centric point load, so minus WAB square by L square. So minus 50 into A is 4 meter into 3 square upon 7 square. So 50 into 4 into 9 upon 49. So it is minus 36.73 kilonewton meter. And MFBD, it is plus WA square B by L square. So it is how much? 50 into 16 into 3 upon 49. So it is 48.98. 48.98 kilonewton meter. Now step number 3. So step number 3 is summation of fixed end moments. Okay. So these will be nothing but PL values one by one. So at 1 we have PL1. What is PL1? Sum of fixed end moments on joint B. So joint B we have 3 fixed end moment values, BA, BC and BD. So BA is 26.67 plus BC minus 15.625 and last is BD plus 48.98. So see how much is this? 26.67 minus 15.625 plus 48.98. So it is 60 kilonewton meter. Then at 2 we have PL2. What is PL2? Let us see what is second location, C. So on second location MFCB is 15.625 kilonewton meter. And at 3 PL3 is there. Where is 3? On D. So MFDB is minus 36.73 kilonewton meter. So from matrix equation we have got these 3 values. Then P1, P2 and P3, all 3 are 0. Why? No external couple. Okay. No external couple. Okay, so these 3 values we have got. I will note down here. 60, this is PL1, 15.625 PL2, and PL3 is minus 36.73, and P1, P2, P3 all are 0. Okay, so just for reference we have written them on the in the corner. Now step number 4, we will apply one by one these values, unit rotations one by one. Okay. So apply unit rotation at B or at 1. So after applying this unit rotation on 1, we will first of all draw the deformed shape of the frame, and then we will mention values of stiffness at all three locations. So here is our joint B or 1. If we rotate this joint by through clockwise direction, then what will be direction of rotation? Something like this. Here 1, and then here. Please see, these two joints I have made fixed. Why? Because I have assumed these two rotations 0 and only this rotation is 1 value. Okay. So this is 1 radian. So here for this I will assume L1. So 4 E I upon L1. This one 4 E I upon L2, and this value is 4 E I upon L3. So again these three members become separately the cases of propped cantilever. This is propped cantilever end, this is fixed. This is propped cantilever end, this is fixed. This is propped cantilever end, this is fixed. So on all the fixed ends we will have half values of these three stiffnesses. So we need these two, we don't need here. So I will show here half value from this end as 2 EI by L2. Okay. Third is here 2 EI by L3. So my first unknown is here. Okay. Second unknown is on C. Third unknown is on D. So I will get now one by one the matrix elements. So what are they? First is K11. What is K11? Moment at 1 due to unit rotation of 1. K11. So how many stiffness values are there on location 1? There are 3. 4 EI by L1. L1 will be of span AB. 4 EI by L2. L2 will be of span BC. 4 EI by L3. L3 will be of span BD. So let us write down one by one. 4 EI by L1 for AB plus 4 EI by L2. It will be for span BC, yes, and third is 4 EI by L3. It will be for span BD. So what is L1? आवाज बंद ना कर. So this is 4 EI by 4 plus 4 EI by 5 plus 4 EI by 7. So let us calculate. This is 1, this is 0.8. Let us see how much is this. So 1 plus 0.8 is 1.8 plus 4 by 7. So it is 2.37 EI. K11 is 2.37 EI. Then K21. What is K21? We have to look at number 2 in the diagram. It is 2 EI by L2. What is this? This is moment at 2 due to unit rotation of 2. 1. Unit rotation of 1. K21. Now why we are looking for moment? Because our second unknown is rotation. If our second unknown is linear displacement, we will find reaction here and not moment. Okay. So in this case it will be moment. So value is 2EI by L2. So how much is this? L2, 2EI by 5. So this is 0.4 EI. K21 is 0.4 EI. Then K31. What is K31? 2 EI by L3. And meaning of this, moment at 3 due to unit rotation of 1. So how much is this? 2 EI by L3. BD. So 2 EI by 7. How much is 2 EI by 7? 0.29 EI. So three values we have got from 1 unit rotation of one unknown. Now we will go to our second unknown, which is theta c. We will make this rotation unit value. The other rotations will be 0. Okay, so let us assume that unit value, draw deformed shape, show the stiffness values, then we will find or write these stiffness values one by one. So step number 5, apply unit rotation at location 2. And then I will again draw the deformed shape. I will show the stiffness values one by one. Yes. So if you rotate this joint clockwise, deformed shape will be something like this. So this is 1 radian and value is 4 EI by L2. Okay, here it will be 2 EI by L2 and here it will be 0. Why? There is no value, half value coming from this end as it is coming to this end, because this is not undergoing any rotation. This is undergoing rotation. These two are fixed. Okay, so we applied rotation on location 2. Locations 1 and 3, both rotations are made 0. So I will now write directly K values one by one, which to start with, let us start with location 1. K1, 2. Why K1, 2? Just like this, moment at 1 due to unit rotation of 2. Okay, so value is 2 EI by L2. 2 EI by L2. L2 is of span BC. So how much? 2 EI by 5. So 0.4 EI. Is it matching with K21? Yes, it is matching. Then K22, second location. What is second location? Here. What is value? 4 EI by L2. So 4 EI by 4. Correct? No, 5. 4 EI by 5. So it is 0.8 EI. This will be unit value. Then K32. moment at 3 due to unit rotation of 2, 0. So these are 0 values. I will just note down these values somewhere. 2.37 EI, then 0.4, and then 0.29. Next 3 are here. First 3 are here. Now 3 more values from next step. Let us find. So now we will apply unit rotation at location 3, our unknown at 3. So we will change this. Step number 6. So where is our third unknown? On support D. So if you apply unit rotation here, what will be deformation? How will it deform? Clockwise rotation. So slope will be on this side. Okay. This is 1 radian rotation. This is 4 EI upon L3. And this is 2 EI upon L3. This is our third location where we have applied rotation. The rest of the two rotations are 0. This is 1, this is 2. So again we will get 3 more K values. Which are those? Let us start from 1. K, 1, 3. Moment at 1 due to unit rotation of 3. What is that? 2 EI by L3. How much is that? 2 EI by 7. How much is 2 EI by 7? I think 0.29. 0.29 EI, which is equal to K13. Then K23. See how much is here? 0. Is it equal to K32? Yes. Because there is no rotation here. Okay. So no moment. Then K33. Moment at 3 due to unit rotation of 3. Where is it? Here. 4 EI by L3. So what is 4 EI by L3? 4 EI upon 7. How much is 4 EI by 7? Let us calculate. 4 EI by 7. So it is 0.57 EI. 0.57 EI. So all values in the stiffness matrix we are having with us except unknowns. Which are unknowns? Delta 1, delta 2, delta 3. So this is equal to inverse of the stiffness matrix. So note down one by one the values now. K11 is 2.37, K12 0.4 EI, K13 0.29 EI, so this will be vertical also 0.4 EI, then 0.29 EI, then K22 0.8 EI, K32 third row second column 0, second row third column 0, and then K33 0.57 EI. So inverse of this matrix into P1, P2, P3 all all are 0 here, minus PL1 60, PL2 15.625 and PL3 minus 36.73. Now we have to solve inverse of this matrix. Okay, so now let us solve the inverse of this matrix manually. We can solve it using calci also, but those who want to know how to solve the inverse of a 3 by 3 matrix, here is the procedure. Procedure is simple. It is for using method of cofactors, but it is lengthy. So what is cofactors? We have to find cofactors one by one. So C11. Here number 1, first one stands for row, second one stands for column. So I shall say, and J. So the formula is minus 1 raised to I plus J. So I is 1, J is 1, so square. So minus 1 square into determinant. Now skip first row, first column from this matrix. First row, first column. So what is remaining? These 4 matrix elements are remaining. 0.8, 0, 0, 0.57. So write them here. 0.8, then 0, then again 0, and last one is 0.57. Okay, so minus 1 square becomes plus 1 into, take cross multiplication, 0.8 into 0.57 and 0, 0. So only 0.456, 0.8 into 0.57 minus 0 square becomes 0.456. Okay. Then C12, which is also equal to C21. So it is minus 1 raised to 3. Why? I is 1, J is 2. Or here I is 2, J is 1. So minus 1 cube. It means from this matrix, you skip first row, third column. First row, second column. First row, second column. It means 1, 2, 3, 4. These are the 4 elements. 0.4, 0, 0.29 and 0.57. So minus 1 cube is there, so it will be minus, okay, or minus 1 into 0.4 into 0.57 minus 0 again. So it is minus 0.29. Okay, answer is minus 0.23. I'm sorry, minus 0.23. Then C13, it is also equal to C31. So minus 1 raised to 4. Why? 1 plus 3. I plus J is 1 plus 3 or 3 plus 1. So first row, third column. Here is first row, third column is here. So which 4 elements? 0.4, 0.8, 0.29, 0. So 0.4, 0.8, 0.29 and 0. Minus 1 raised to 4 is plus 1 multiplied by 0.4 into 0 is 0 minus 0.8 into 0.29. So it is 0.23. Okay, so it is minus 0.23. Then how many elements we have got? 1, 1. So here 1, 2 here, 2, 1 is here, 1, 3 is here, 3, 1 is here. So 1, 2, 3, 4, 5 elements we have got. Now C22. C22 means again minus 1 raised to 4. Second row, second column. Here is second row, here is second column. So 2.37, 0.29, Next, second row, second column. So 0.29, 0.57. So minus 1 raised to 4 is plus 1. So 2.37 into 0.57 minus 0.29 square. Okay, so this is 1.27. 1.27, correct. So sixth element is obtained. Now seventh and eighth we will get, which is second row, third column, C23, which is also equal to C32. So minus 1 raised to 5 into second row, third column, second row, third column. So 1, 2, 3, 4. So 2.37, 0.4, 0.29 and 0. So it will be minus 1 raised to 5 is minus. Okay, so minus 2.37 into 0 is 0. So minus in bracket 0 minus 0.4 into 0.29. So it is 0.12. And then C33, last one. So it is minus 1 raised to 6 into third row, third column. Third row is here, third column is here. So these 4. 2.3, 0.4. Then again 0.4 and then 0.8. Okay. So minus 1 raised to 6 is plus 1 into bracket 2.3 into 0.8 minus 0.4 square 1.68. 1.68. So these are 9 cofactors. Okay, so let us proceed ahead. I will keep this because I need it for reference. So delta 1, delta 2, delta 3, it is equal to, first of all go for determinant. So 1 upon EI into bracket. Now carefully see determinant of 3 by 3 matrix. C11 cofactor 0.456 into first row, first element 2.37, then first row, second column, first row, second column minus 0.23 into 0.4. Okay, then first row, third column. So again minus 0.23 into 0.29. This is determinant of 3 by 3. The value in the square bracket multiplied by. Now enter cofactor values 1 by 1 here without EI. Okay, so 0.456, then minus 0.23, then again minus 0.23, then C22 is 1.27, C23 is 0.12, last is 1.68. So this is inverse of 3 by 3 over. Next 0 minus 60 is minus 60, 0 minus 15.625, 0 minus minus plus 36.73 over. We will go for finding out the unknowns, that is delta 1, delta 2, delta 3. So delta 1, What is delta 1? 1 upon EI. Let us first of all find determinant value. So 0.456 into 2.37 minus 0.23 into 0.4 minus 0.23 into 0.29. So it is 0.92 EI. Okay, 0.92 EI into multiplication of matrices. 0.456 into minus 60. Okay, minus 0.23 into minus 15.625 minus 0.23 into 36.73. So it is minus 32.21. So minus 32.21 upon 0.92. So it is minus 35 upon EI. Okay. Then delta 2. Now delta 2. So minus 0.23 into minus 60 plus 1.27 into minus 15.625 minus 0.12 into 36.73. This value divided by again determinant 0.92. So it is minus 11.36 upon EI. And delta 3 minus 0.23 into minus 60 minus 0.12 into minus 15.625 plus 1.68 into 36.73. This value will be divided by 0.92. So it is 84.11 upon EI. Okay, 84.11 upon EI. Once we have got these values, what we need is final moments. So next step is final moments. So these are final moments. MAB is 35.375, MBA minus 8.15, MBC 13.75, MBD minus 5.565, CB and DB both are 0 because C and D both joints are hinge type of joints, and net value of moments on joint B. So if you take addition of algebraic addition of all these values, it will be 0. Okay. So if you have not understood anything, any part, if you want any clarification, you can ask in the comments. Thank you for watching. If you are new to this channel, do subscribe the channel and let me know your reviews. Thank you very much.